we say that two lines are parallel if they both have the same slope. And what this means graphically is that if you had, let's say, one line that looks like this, and you were going to graph a parallel line, then the tilt of the line, the steepness of the line, would need to be exactly the same. So like this would not be parallel because one would have a slope of maybe 5, the green line, and maybe the blue line has a slope of a half. And so those don't have the same slope, and they don't run side by side or alongside one another. But if we take this blue line and maybe put it like right, let's say here, for example, it looks like they're running side by side, and it doesn't look like they'll ever cross even way into the distance. If the slope is exactly the same, then these guys will never cross one another. So let me make up a couple equations for these, and I don't know exactly the equations of the green and blue line, but we'll make up something that closely resembles these guys. Maybe the green line is y equals x plus 4, maybe. And the equation of the blue line is y equals x minus 3. So these guys would be parallel. Now, how do I know? Well, look at the slopes of each of these. The first equation has a slope of 1. There's an understood 1 here. And so does the second equation. So for both of these lines between one point to another, you could go up 1 over 1, up 1 over 1, up 1 over 1. And so since they have the same slope, then they're going up at the same rate, and they'll never ever cross. Now, another thing you'll notice about parallel lines is we would actually expect them to have different y-intercepts. The y-intercepts have absolutely no bearing on whether your lines are parallel or not. The y-intercept is simply where it crosses the y-axis. And if your lines are parallel, they're probably going to cross at a different place. And so don't think because these numbers are different that they might not be parallel. It only has to do with the slope, or the m, when you write y equals mx plus b. So just keep your eye on this m, and it'll tell you if your lines are parallel to one another or not. Okay, so just to be clear, if you're trying to determine if two lines are parallel, if let's say you're doing a homework problem and you're provided two equations and maybe you're not even given the graph, and they say, are these two parallel? Here's what you're going to do. First of all, you're going to put both equations in slope-intercept form. Now, why would we want to do that? Well, when it's in slope-intercept form, you can easily see what the m is. You can see what the slope is. And then it says, and investigate the slope of each line. So like, look at this example here. I have y equals negative 2x plus 7 and y equals positive 2x minus 3. The plus 7 and the minus 3 have no bearing on whether these are parallel or not. They don't matter. But what does matter is the m. So I'm going to look at the m for the first equation and the m for the second equation. The slope of the first line is negative 2. The slope of the second line is positive 2. Those two lines are not parallel because the slopes don't match. All right. Now, what will often happen is they'll give you two equations, but they won't make it quite as clear as this first example. This first example, it was primed and ready to go. You could look at it and just answer it. But typically what will happen is, maybe one of them might be in slope-intercept form. Like this guy does have a slope of negative a half, but we don't know the slope of the second equation yet until we do a little work. So for the second equation, let's go ahead and try to solve this for y using some algebra. So first step, I think we'd subtract x over to the right. We get 2y equals negative x minus 10. And then we'll divide both sides by 2. So we'd get y equals not negative 1x, but negative 1/2 x, because we divided by 2, minus 10 divided by 2, which is 5. So this equation and this equation are really the same. We just changed the way that it looked. And once it's written in this form, I can very easily see that yes, these two guys are in fact parallel to one another. So you put it in slope-intercept form, and then you just investigate the m. And just to repeat myself one more time, the 9 and the -5 have no bearing on whether these two guys were going to be parallel or not. The 9 and the -5 could have been anything, and these two lines still would have been parallel to one another. So just to close up this example, I actually went ahead and graphed this equation here, actually both of them, and sure enough, you can see they are going in the same direction. It clearly does look like they have the same slope, and it doesn't look like these guys are ever going to cross anywhere in the distance. So in fact, these two guys were parallel to one another.